proposed for both lamps and lasers, but there's a lot of questions on the part of safety people as to whether we should be really using a symbol rather than language. And the problem, of course, is for universal standards and for products sold worldwide, warning labels that are just in one or two languages are not so helpful. So there's quite a debate, as you can imagine, in the International Electrotechnical Commission on what constitutes a meaningful label. My personal feeling is this: if you see this on a lamp or a laser, you can figure out what it means. But what some of the opponents to this idea show is that if they just show this to somebody on the street and not tell them what it is, most people don't understand what it's for. So it has to be seen in context. I was going to entertain some questions, but I also want to just mention that in practical safety, in medical laser safety, for example, there are two trends that I mentioned right in the opening that I wanted to mention. One relates to whether we need a laser safety officer, a laser safety advisor, or someone in every operating room theater, which is often opposed by surgeons, or should we emphasize more training of everybody? That's been one issue that has been around for a decade and still plagues us, because there's always two positions on this. And the second thing is that as manufacturers of laser products improve the system safety and make some surgical lasers smart lasers, so they already tell you, or they already make some decisions and recognize a fiber break or recognize a lack of contact with the skin or what have you, that we have to relax the safety requirements in order to encourage the use of smart lasers. And so this has been a debate, because a lot of people who are used to having very stringent user control measures in the operation of lasers are not always willing to eliminate some of those safety precautions, such as use of eyewear and things, even though all of this system safety has been built into the newer products. The manufacturers say, well, why do this if we don't have some benefit, such as a relaxation of the user safety standards? So those are the two big sort of political issues that are swirling around in medical laser safety guidelines. So I think that covers the key points. Thank you.
All right, thank you. Thank you, David. Very informative and containing the very latest information for us. If it's possible, let us take this opportunity to raise one or two questions to David. Are there any questions in floor? Yes, please.
Professor Sliney, as a surgeon who uses almost entirely the CO2 laser, what I have been doing in my own practice is insisting that the laser must never be switched on if the handpiece isn't in place. Because once you have the thing in focus, then if the focal length, for instance, is 5 centimeters, anything more than 5 centimeters from the focal point is harmless, and I've been able to demonstrate this. So that we don't bother very much about all these signs you have on the doors and all that sort of thing. I simply insist that you do not switch on the laser unless you have the handpiece in position.
Yes, you've very nicely summarized the position of a lot of surgeons who feel that the important thing is system safety, which would be, for example, to have an interlock switch on the delivery piece so that the thing wouldn't go on without some servicing override in normal use. And in fact, I think that's actually in the American user safety standard, that there should be a smart sensor built into the thing to do exactly like that. And exactly as you say, most laser products used in surgery, because they're focal in nature, the beam diverges very rapidly, and so the hazardous zone is quite limited. And the other thing that surgeons say is, for goodness sakes, we're working with all sorts of very dangerous things like scalpels and everything else. Why are we paying quite so much attention? Of course it was important when lasers were very new and you were just giving your first lectures and so forth, that we had a great deal of attention paid to this subject, but many surgeons would argue that we have a bit too much overhead, and the laser industry agrees in the sense that they feel that if you have a lot of administrative burden in order to use a laser, you're liable to just use an alternative technology, which is not really good for the patient or the surgeon if the laser is really the better surgical tool. Another question or comment?
Another questions? And if not, it's not a question, but my personal comment. But I think the safety, as you have mentioned today, is a very important and an essential knowledge for the person who will use the optical technologies as medical technologies in the clinical arenas. And I think that not only for the medical physicians and medical co-workers, but also for the ordinary person, because you have mentioned that the LED, and I think the LDE is the next candidate, very big candidate for the lamps, which will be used in the ordinary life. So we have to focus on much more safety for the blue light, and as you said, that another aspect for the endocrine effect or something like that.
Right, thank you. I might just comment that with LEDs, because we have a lot of energy in narrow bands now possible, it's not impossible that there have been biological effects that have gone unnoticed. All we have to do is think about all of the discoveries with regard to low-level laser therapy and the photochemical interaction mechanisms down at the subcellular level to recognize that there can be effects, and they may not all be beneficial. So that we have to be a little bit careful as we apply new types of light sources which we did not evolve under. Sunlight, and fire, all are very broad band sources with a little ultraviolet, great deal of visible and great deal of infrared. And we have sensor mechanisms to say, that's hot or that's bright, and turn away. That may not always be true for some very narrow band sources.
Thank you.
Thank you.